Hi everyone, and welcome to Trusting AI to the Modernize software at scale. Let's wait a quick minute for the slides to show. Is it not? Does help a bit. In this talk, I'll take you through our experiences at Modern at working with AI as a company that aims to make reliable code changes at scale. That might then seem like a bit of a contradiction to be using AI at all. But we're going to look at how we've actually made that work. I hope that you'll learn from our pragmatic approach at using AI to see how you can use that technology for your own projects. So that's the goal here today. And we'll be doing that as a bit of a speed run because the good parts are always near the end of the presentation. So first up, this is me. My name is Titre, and I'm a solutions engineer at Modern. But I'm also the community lead for Open Rewrite. I'm a big fan of contributing to open source software, as you can see from the green bar over there. And once in a while, I'll do presentations like this one. And perhaps good to note that I am not an AI expert. But helpfully for me, I work at a company where we actually do have folks on staff who are writing books about how to use AI. So that's very helpful for me when presenting and preparing a presentation that you actually have a book to go through. Now, we had a researcher working at the Mila Institute in Montreal, where she was working together with other researchers to bring groundbreaking AI work to our company, which has been very helpful, and she's also helped me prep for this presentation. Now, I work at Modern, which, if you're unfamiliar, Modern is the main sponsor behind Open Rewrite. And I'll tell you a bit about both because it applies to how we actually are using AI in the work that we do. So Modern is a commercial platform designed to allow you to run the Open Rewrite recipe catalog at a large scale for large companies, enterprises that aim to do software modernization, resolving vulnerabilities, upgrading their applications, or improving code quality. Now, we offer Modern for free to open source projects, but we also to help maintain the projects that we have come to rely on. But we also offer that to our customers, which are typically large banks and insurers. So if you've never heard of Open Rewrite before, then you might want to look sideways a bit because it's pretty much the same logo. It's just tilted 90 degrees. So Open Rewrite is a safe code refactoring framework, mostly written in Java, but it's usable across a range of languages. It allows you to automate the boring parts of upgrades. So if you want to do some maintenance, you want to reduce technical debt or improve code quality or security, you want to look towards Open Rewrite. Now we have some 4,200 recipes available for you for languages like Java, TypeScript, C#, and Python still to come as well. Now, Open Rewrite is Apache licensed. It's open source. It has plugins available for Maven and Gradle to upgrade a single project at a time. You can go to GitHub, see exactly how that's worked. It's using parsers and plugins and to make that work. But it's also increasingly being integrated into other tools. So if you are using Modern JetBrains IntelliJ Ultimate Edition, then you already have Open Rewrite installed on your laptop. If you're using a tool like Amazon Q or GitHub Copilot, those are all just using Open Rewrite underneath. So if you've never heard of Open Rewrite, then that's already a big boost for you today. But it's also not very new because we've been doing this for 10 years. So if you've only done any of these upgrades manually over the past 10 years, that is unfortunately a bit of a waste. I always like to use this example when explaining what you could be doing with this technology. So you've all hopefully by now upgraded to JUnit 5 because JUnit 6 is coming out in a couple of months. So really you want to get rid of JUnit 3 and 4 already. But that transformation in isolation on a small example is typically very simple. You'll have in the old way in red here a annotation at the top which says that I'm expecting an exception of this type. And then with JUnit 5 they've since moved that into a method that you need to call with the same method body, but then hand it off as a lambda into the same. So while a lot of folks in the past maybe have migrated with regular expressions, this is the type of work that you really can't do with a regular expression, because how are you going to match that reliably? How are you going to make that change? And then maybe you'll manage for the simplest cases, but if you have a couple thousand, pretty much you'll find that your regular expressions are just not going to help you there. So the way that we're able to make these code changes for you, again, using those Apache license, Maven and Gradle plugins to do these migrations, is by building up a very detailed model of your code. That model, as you can see on the left, we call it a lossless semantic tree. It's analogous to what you would see with an abstract syntax tree, but then enriched with further data. Because what abstract syntax trees typically do for you is the first thing they do is throw away your comments, throw away your formatting, and then good luck at making source code changes when get those accepted by your team. So we keep those in. We also add in type information, such that you can be sure that when you are matching a particular annotation or a typical method, it's the exact one that you want to do. And then once we have that model, we apply the visitor pattern to traverse that model, make code changes, and get reflected in what you actually want to be using instead. Now we have that for a variety of technology. Like I said, we have 4,000 plus recipes that you can use in this way. And this is very much, it underpins all that we do with Open Rewrite and Modern. But we've also open sourced that model. The reason that IntelliJ and Amazon and GitHub are able to build upon that model is because the core of that is open source, because we think that everyone should benefit from having that better data, better tools to be able to upgrade their applications. So what we then do at Modern is to allow you to go beyond that single project that you work on. So when you have a large bank and you want to run your upgrades there, then we make that possible for you to do that at the scale of thousands of projects. So we have customers who are quite literally are maintaining 200,000 Git repositories in this way. And that then influences how and why we're using AI and how we choose to do so. Because when we make code changes, there is a lot of trust involved. If you're going to change a couple million lines of code, you don't want to review a couple million lines of code. So when we make code changes, things should just work, and such that you don't necessarily have to review everything. So then it might come as a bit of a surprise to introduce an element which might be unpredictable, which we have with AI. So like I said, we have customers both small and large, but typically these are large financial institutions. They really like predictable outcomes. So they want accurate and repeatable changes, and if you had a couple million lines of code to maintain, then probably you would like that as well. Now what we found is that these types of customers, they either love AI and the promise that it gives to help maintain millions of lines of code, or they absolutely hate it the moment we mention it. They ask for a button to turn it off, which is interesting, building out capabilities when you also have to make it optional every step of the way. We've even had some customers who would love to use the tools we have, but they only have budget for AI, so it has to be in everything, and otherwise they couldn't buy. So it's a very interesting set there. So in that context, we're going to look at how we're using AI, which is very much unpredictable, and still try to derive value for our customers such that you can use it with trust at scale. And ideally, we want to do so without massive expense, because we are a startup and we're competing with companies like JetBrains, Microsoft, Amazon, trying to do some of that same. And the way I'll take you through this talk is through this hype curve. You've probably seen this hype cycle before, and I've used an example at the top here where if you, for a period where new technology comes out, there's a peak of inflated expectations. You'll see if you look closely, there's a blockchain for cat food. There's actually a blog out there where someone thought a blockchain was the solution to how to reliably create new cat food. And if you swap out blockchain for AI, you're going to find recipes for cat food, which someone thought AI would be the perfect solution for. Things always get a bit weird when there's new technology out there. But soon enough, you'll see that trough of disillusionment, where suddenly it doesn't really deliver on the promises that it creates. And then from there, you'll need to find that slope of enlightenment, find the places where it's actually good to do something before you reach some productivity again. So I'll show you how we started, how we had big expectations, how we had to scale back, and what we have arrived at since. So When we started, we had high hopes because, of course, at the time we had some 1,000 recipes in our catalog to allow you to upgrade large parts of your application. But we also had gaps in the coverage that we had for technologies. Now, initially, folks would be amazed that we were able to upgrade any part of their application at all, going from JUnit 4 to 5. These days, we are getting complaints that we're not upgrading their internal libraries and frameworks out of the box as well, which is a bit interesting. It's a thing that we had to remedy. So what we thought was that AI and ChatGPT and all of those technologies would allow us to build out that recipe catalog. You would just say, well, I have this, I want this, could you write me a recipe to do exactly that? And that's what our colleague Justine did at the Meta Institute. And initially, when she saw the output, it looked quite okay. But to the untrained eye, it looked actually quite convincing as a recipe of what to do. But if you look closely, then it turns out that there were quite some big problems with it. Because for starters, it didn't really compile. It was just red curly braces all over the place. And then if you look even closer, it was using methods that don't exist at all. And if you look beyond that, we of course used the visitor pattern to traverse that model. It had no sense of doing so at all. So while it looked convincing, it had nothing of promise to be actually close that gap in coverage that we had. And this is a very common problem with AI. It's very hard to combat these generative elements that are going to dream up something that just doesn't exist. So then we looked at how can we scale that back? How can we reduce the problem to something that is maybe good at? And for that, we tried to implement a recipe that we already had to fix a sonar violation, where if you have a switch statement, and there's two non-compliant examples on the left, they want you to put the default case last, because they think that is the most readable way to have a switch statement. So they want you to move it to the right-hand side. So what we set out to do is, with this reduced scope of just one switch statement, we hand it off to OpenAI with the instructions, make the default case the last one. And this is how that is implemented. Now, you don't have to read all of the lines, but just notice that the one line in green, that is our instruction that we sent off to ChatGPT. So in this case, we're going to find any switch that we have. We're going to look if it has a default case. And if so, we're going to take that whole switch, we're going to send it off to AI, we're going to ask it, make the default case last. And I would absolutely love it if all our recipes were this simple, because it's just one line that you have to get right, and then you get the results that you want. Now, when you run this, it does actually work. Some of the time, because if you run it again, you're going to get a slightly different result. And if you run it 100 times, you're definitely in trouble. So I can do a very fun demo, which I'm hoping someone of you would want to do, but because this is a bit of a gamble. I'm telling you, you should do things rules-based, whereas AI is able to do this as well. So any takers who want to see me give a demo that if it works, I'm out of a job. Yeah, let's see. I'm gonna mirror displays, and I'm going to switch to this one, and I'm gonna zoom in a bit. So here we have that recipe that we have. We take the visitor pattern. We're going to find any switch. I hope this is somewhat legible, and then we're going to hand off the entire switch to AI. And then we have this part, which actually takes that switch, it prints it nicely, it sends it to OpenAI, and with the instructions that we want to edit this, and whatever response comes back, we're going to one-to-one swap in with the switch that we had, and then see if it all works. Now, in all honesty, I'm using GPT-4o here, just because that's the last time we updated the API to interact with, but we're going to see how it actually performs. And for that, I'm going to run my test and hope that the Wi-Fi holds up. And then I have two tests here. One test is to actually check that if we send in this switch, where you'll notice that the default case is not the last one, then I one-to-one expect this exact output. It should move the default case to the last one, and that case 2, which has a fall through, I want to move that one as well. So then if we look to see for the test, it's still running the other ones, then I'll show you that the results are going to be unpredictable. You'll notice that I'm running it as a repeated test. And what we're going to find is that not a lot of these repetitions are going to give the same result. Now I also have a second test, which is also interesting, where we actually have a switch statement which already has a default case last. So it should be doing nothing at all as we hand it off because it's already done. But it's still, we're going to find that it tries to do something still. Let me try to open up the tests that we're running. So here we have that test where we're expecting nothing at all to happen. And then, like an overly eager intern, we find that the AI really can't help itself. It wants to do something at all. So it's going to add some comments here, which isn't great. I didn't ask it to do so, but overeager as it is, it's going to do so. And we had a couple of iterations fail in the same way. So let's see what the second one does. This one is even more interesting. We had a problem running things and getting something back from AI, and then it's just the complete response that we got from our agent, which has been swapped in. Also not great when you want to do things reliably. So third one, let's see what it does here. It again adds some comments, but slightly different comments than the first one that we saw. So clearly not great when you want to get reliable code changes. So then let's look at the ones where we actually do expect code changes. So in this case, we are going to see the changes that it does. You'll notice before we had that fall through, it actually adding in the error and break in case 2 as well. So it's duplicating some logic. Again, not what we asked for, but we can say, well, we'll tolerate you doing that one. So we're going to add this one and say, well, let's run it again and see how you do that. So again, we had, let's see if we can see some more variations. Here we had a different one, also adding in the same statements. So at least some consistency there. Again, some consistency here, but now the case 2 is in the original position before case 1 instead of moved closer to the default one. So really, you're not getting anything predictable at all. Let me see if we find the last one. Just going to run this again. So we've already adapted our expectations to fit what it's doing in some of these cases. But then still, if you run it 20 times, then you're going to find that at least some of these are going to be very different. So the first ones are decent, but there's a reason I picked 20 iterations, because I'm finding that usually within the first 10, it's going to diverge again from what I set out to do. And clearly, this is not great. If you're going to have a switch and you're going to run a recipe, you probably want to have the same result every day and not what it's doing here. Again, an error running something and then it just completely fails. Here, there's a different one. What do we see now? It's moved case 2, kept that above case 1. So again, very much showing that this is not going to give you the reliable results. And now try to extrapolate this to having not one switch that you are actively looking at in your IDE, but having a couple thousand or tens of thousands across your entire organization. And then you're not going to get the results that you're after. So with that, let's go back to the presentation. Hope it all works. Yeah. So we now have a lever. We have something you can pull and maybe you'll get the result you're after. That is a very convincing business model. There's a whole building here that operates on that model, that sometimes you'll get the results you want, but oftentimes it doesn't really do that. It's very lucrative, but it's really not solving a problem for you. It's actually giving you a different problem to deal with. Now you can improve the results that you saw. You can give it further instructions, like don't change the order of the case statements, keep the logic exactly the same. But what you're going to find is that natural language is limited in the expression of what you can actually define here, because soon enough you'll start to program in something like this and then still have a model that doesn't really interpret that the way that you had intended to do, because natural language isn't a great fit for programming. And then still it remains unpredictable. It forces you to review all of the lines of code that are changed, because it's not going to give you a guaranteed rules-based changes here. So we see this with some of our competitors. If you look to Amazon Q and GitHub Copilot, Upgrade Assistant for Java, what they do is they take our rules-based approach, they sprinkle a bit of AI on top, and what you then get is, while you started with predictable changes, now you also have to review every line that they've changed, because some of the AI might just change some of those lines to the point where you now can't be certain that what it does is correct. So this is pretty much, going deep into the trough of disillusionment. Our customers, they want predictable results, but it doesn't really materialize just yet from using this particular technology. So what then is a good use case for AI? We searched a bit, and what the minimal viable product is that we can deliver using this technology. And for that, we came to our search, because our search was pretty mediocre. We were a Java shop using some old Lucene version that we just built initially to do some search on our recipes. It worked really well when you have a couple hundred. It worked really poorly when you go over 1,000 recipes, and nowadays we have 4,000, so it's really started to hurt a bit. And while we could have switched to a different solution that allows for better word stemming, things that just weren't in an old Lucene version, or upgraded to a newer Lucene version that does things slightly more but needs a lot of tweaking, we thought we should be doing something different, because this just didn't scale well, and we figured that AI could be a good solution here. Now, we did a very naive first attempt where we said, well, we have a complete list of recipes. Here's 1,000 recipes plus their descriptions. Go find me the one that most closely matches the query that the user has put in. And this just didn't work very well, because we saw some problems, as in it started to find a recipe that didn't exist, because it started to hallucinate again, and here's the result you're after. Turns out it doesn't exist. Isn't a great experience when you're doing search. It shows complete coverage of everything you want, but it just doesn't work when you want to run things. So then we did a better approach to say, well, okay, instead of getting confused by a very large output, let's go do some retrieval augmented generation, where we take the query that you have, we turn it into a three-dimensional float vector, and we have done the same with all our recipes. And we're going to find, for your query, any recipes close in the space that we have to try to find some semblance of what is related here. Now, the nice thing about this approach is that it also allows you to search for things that are maybe not identical, but very close in meaning of what you're looking for. Because previously we could only find the exact word that you were looking for. But if you find that we have recipes that are like change up the dependency, upgrade dependency, bump dependency, rename dependency, all of those, you would need to know exactly which word to search for. Whereas if you use this approach, you can actually find words close together in meaning to still find these things. But when we did some validation on this approach, we had dozens and dozens of search terms and a recipe we thought it should be finding. We found that we got 1 in every 20 correct. So that is a very mediocre score. This was the absolute low point in our attempts at using AI, because we wanted to generate complete recipes and we couldn't even get search to work. So Justine went back to her colleagues at the Mila Institute, and it turns out you can't really use embeddings for search unless it is specifically been trained for retrieval. So this is a lesson for us, that you need to be very deliberate about your choice of model and the way what it's been trained for, what it's good for when you want to use these technologies. And from there, we landed on something like a better model that does support that retrieval search, and then this workflow to make that work. So we still take your query and the recipes that we have, we try to find which ones are close in space. We have a bit of a cutoff based on distance, and then in a second iteration, we re-rank the ones and filter on the queries that are definitely not the thing that is related to your search, but just maybe were picked up accidentally. And then as a final step, we do reordering to filter out or bubble up the recipes that are probably most closely related to what you're searching for. Because if you're searching for Java upgrades, you want to have the Java 21 upgrade first, then 17, then 11, then 8, and so further down. Now, there was a bit of effort looking at models. If you go to Hugging Face, there's a big comparison there. They also have benchmarks, like the massive text embedding benchmark that we use to find a model that works very well for us. But you'll also notice that they'll have very wildly different characteristics. So you want to be careful here, because if you pick the wrong one, you're going to need 50 megabytes of memory to run anything at all, while as one that only needs 1 gigabyte might have same characteristics as well. So then we, like I said, landed on this workflow, and it works very well. But then if you want to know more about this, I'm going to skip a bit just for time. Then I suggest that you scan this QR code and get a blog with all the details of what you want to learn here. Now I want to very briefly demo this, because this ties in again with some needs of our customers. And this is, I'm going to show you the recipe builder. And for that, I'm going to mirror again. Now the recipe builder is something you can use as well. Probably you'll have some internal libraries or frameworks that you want to upgrade. And then we have this view for you to be able to find recipes, compose recipes, and do so. So in this case, we're going to search for a recipe, maybe to bump your Maven parent pom. And this, I would hope to find the recipe that indeed upgrades your Maven parent project version. So we used bump as a search term, but here we can open this one, add it, fill in some arguments like com.acme.parent, internal parent, and say I want to upgrade it to version 3.x. And now you've written your first open rewrite recipe to do exactly this. Now notice that every time I open up that search, it is very quick. That is a problem we had initially with Lucene and other approaches, that you actually want to be able to find things very quickly, and you want to be able to add things to this without having to wait a couple minutes to get a result, because that's very core to what we do. And this also then allows you to find our Spring Boot 3 migration recipes, and you'll find that the ones that you want are at the top, and then it's that reordering that actually works very well. Now, this works. We're very pleased with the responses you're getting. But now keep in mind that we also have customers that don't want to have any AI features in their application. So we built a toggle here to make Justine very sad, where you can disable all AI features and you'll get much more mediocre search results, just because we had to be compliant with some more regulated banks and instances there. So know that this works, you're able to use that as well, and I hope that then helps you compose your own migrations to do that type of work. So then with that, let's look at a couple more use cases that we had. So search is nice. If you know what to search for, you will now able to find it, but we would much rather give you recommendations, because with an expanding catalog of some 4,000 recipes, we don't want you to have to search for things explicitly. We just want you to give us source code access, and then ask, like, what would you actually be running on this software to be improving it. So we landed on this prompt, something that you give to AI and it's able to scan your code. And then in this case, this worked quite well. It gave you some suggestions, but we found one way that made it a whole lot better, which is add the word senior to it. This is playing around with these prompts. You'll have an interesting day, and this is something that we found greatly improved the suggestions that we got. And then you would do something like this. You take a snippet of your code, you pass in that prompt, you're a senior software engineer, what would you improve? Give me 3 suggestions. And then you get something like this, a suggestion to upgrade to Java 8 or later, because the Boolean class was introduced in Java 5 and has been deprecated. That is a load of crap. It's just very much not true. That's one of the elements of generative AI. It's gonna give you something. There's no fact checking at all. But the nice thing is, if you take this query and you pass it into our search, it clusters very nicely with the recipes we have to upgrade Java applications, meaning that if you the recipes you find are gonna probably do some improvements on the code that you have here. So again, we're able to leverage the search that we built previously, and despite having unpredictable outputs like this one, still are able to generate value by recommending some recipes to you. But then you get into problems of scale because our customers, they are very large banks, insurers. Like I said, they'll have something on this order, like 1,200 repositories or on some department, and then they'll have a couple million more maybe in different across the entire company. And if you then want to do some searches, then you're going to run into performance issues. Because if you take a pipeline that's decently tweaked, it takes about 3 seconds to generate a recommendation for a snippet of code, and then from there find the recipes. Then come to discover that you have some 400,000 methods where you might want to get some generated recommendations for. Then you're going to have to wait 2 weeks to get your recommended recipes to run. That is not going to work very well, doesn't go over well, and even if through some heroics you're able to speed things up 50%, you're going to have to wait a week, which is still not going to be acceptable. So we set out to reuse the component that we had for embeddings, but now instead of looking to cluster recipes together, we're going to cluster method declarations together. So we take from your entire application or organization space all the method declarations that you have. We cluster them in a way that groups together the ones that are very similar. So you'll have a cluster of just plain setters and getters. You'll have a clusters of things that do something more interactive with HTTP requests. You'll have a cluster of database accesses. And then if you take representative samples of those clusters, and for those representatives generate these recommendations, you're going to get some recipes suggested to you that actually do something meaningful, probably for the entire cluster. So this is a way for us to massively improve the performance of what we're doing and still get value by recommending the right recipes for you to upgrade your applications. Now the entire workflow looks something like this. It's just we use that, clustering the sampling, generate the recommendations, and then using that prompt to your senior developer, give me 3 recommendations, and then all told, you'll get some recommended recipes to run, and you'll be able to upgrade your application. Now, if you want to know more details about that, there's again a QR code you can scan. And this then is a very helpful guide towards the recipes that you want to be running. But then we had some more interesting cases coming from our customers directly, because we had one which was using a particular identity access management provider, like a vendor API that they had integrated with. And then that vendor decided, well, now that I'm integrated all over the place, you have no way to go. I'm going to triple your price in the next 3 months. Good luck. And the customer, they came to us and they thought, well, we're not quite happy with that contract that we have. It was going to look to be very expensive and painful to move away. So they actually wanted to find a way to get away from that vendor. And they came to us with this query, find all HTTP requests that set an authorization header, and asked if we could be able to find all of these through our tooling that we have. Now, we have ways to do this type of search. If you know the HTTP libraries you're using, we can find those already. But if you don't quite know which HTTP clients you're using, then you're going to have a challenge to find all of them, replace all of them, and move away. It doesn't really help to, you can't really move away from that vendor until you're finally fully migrated every instance that you had. So what we then did is we tried to saw this as a project where we could again use AI to find HTTP clients that were using a particular header which was unique to that vendor, and then find all the instances where that was being used, and then write recipes to move away from that exact case. So a very typical type of questions for our customers, but it's a somewhat complex flow to be able to work that out. So the solution that we landed on is, again, embeddings to be able to find method invocations that are closely related to the query that you're after. I'm looking for HTTP requests including a particular HTTP header. And then the problem that we had for this case specifically, as compared to the last one with recommendations, is that with search, you're not really able to do sampling. Because if you're going to sample, you're going to not find things, and you're going to then not be able to migrate those, and you'll miss out. So that's a bit of a challenge that we had with the first iteration here. We came to find that we could build a search that does this, but it takes you 10 hours to get a result. And again, that is not going to go over well with the customers that we have. So then what we did to improve this is that we figured out, well, some of those method invocations that you're doing, those are probably very similar to other method invocations that you're doing. And some might be even the exact same method invocation with the same arguments, just in a different location in your code. So what we're going to do here is then to find those, again, using this particular workflow, where we take the query that you have, we're going to find recipe, we're going to find method invocations that are clustered here, and then we're going to find the corresponding method declarations. We're going to find the associated Java docs for those methods to figure out if they're actually closely related with that clustering that we have. And then we come to a series of models that will say for this particular method invocation, yes, I think this is a HTTP header being passed to a vendor, or no, I don't think it was, or I don't know, and I'm going to ask the next model to do so. So this chaining of 3 models means that we're able to do a selective filtering step until we land on just the libraries that we need to inspect more closely. So in this case, for the first one, we're able to use a very small, fast, cheap model to run. The next one can be slightly more complex because it can be more expensive because the search space is already smaller. And the last one can go full in depth to find just the ones that we're interested in. And this then allowed us to find all the HTTP clients that they were using, even a couple that they didn't know that they were using, because it is Java after all. You probably have a couple dozen in any org of any size. And then we're able to migrate away just because, just before that 3-month deadline came up. But it is a realization for us that our customers are going to continuously be coming up with these types of questions. And while I and my team are very adept at helping them through the tools to actually solve these types of problems, we figured that, well, since they're going to keep coming, probably we need to build something that is going to help them explore that space themselves. So especially now we have an ever-expanding recipe catalog of some 4,000 recipes, we increasingly were getting questions like, do you have a recipe for technology X, or how can I best do this type of use case that they're after? And while we initially only got these questions from customers, with expanding the team, we got them from internal colleagues as well. And this is just part of growing and the growing pains that you then have, that not everyone knows everything anymore. And we had a system, and that system was kind of called like Just Ask Tim. But the problem was that went down every night, and it's sometimes entire weekends unavailable, and it just didn't scale very well. So what we then set out to do is we wrote an agentic AI experience to be able to help you guide through the patterns to use these recipes, leveraging the model context protocol functionality of tool calling. It was added somewhere like December last year. And that is, we found that has very much taken away the intricacies of choosing the right model, because now that you have tools that you can add to those models, you don't have to be reliant on any training that has gone into that model so much, because the tools will provide the differentiation that you need. And in that sense, we found that models are somewhat commoditized, and now you can just use exposed tools to those models to be doing what you want. So if you take that off-the-shelf model and provide it with better data and tools, you're going to get a better result with less hallucinations. So this then is the flow that we developed. So we took the recipe search that we developed initially, where you can add in natural language queries to do exactly what you want. But we now expose that as a tool to our AI model, such that if you come to us with a query, the AI will know to call that recipe search, get back a list of recipes, and then call the next tool that we have to run those recipes on your code. And then look at the results, analyze those, maybe even build up a data table of those results, and then from there do further processing to answer the question that you have by jumping back and forth with the tools that we have, just a handful, and building out that flow to give you an answer in natural language as a summary of what you want to do instead. And then it does mean that you have to be very deliberate in the way that you expose the tools that you have. Now, I told you previously, you can't really give 1,000 recipes and ask an AI to pick the right one. It'll get lost. Similarly, you can't give it 1,000 tools and suggest that it picks the right one. So you want to have tools that allow you to guide and pick the right one, and then verification to check that what you've done is actually any good at all. And the way that you expose those tools, it is very simple. It's very much simple, pretty much like you saw earlier with the switch case that we had, where you just, most of it is just instructions that you pass along. And then there's one line of code in here, which is the line 21, which actually calls out to the search that we already had. And the rest of it is just instructions for a model to know when to call this tool, how to call this tool, and what to do after having called this tool. So this is something that you can already use yourself as well. You probably have something that is of value already if you can expose it as a tool for an AI to call. And I can show a bit of a demo here if all is working well. We've had some problems, unfortunately, with Anthropic, which we're using in this case. Let me try to switch to mirror. And like I said, we're using Anthropic at the moment, which is usually quite good, but not today for some reason. So we'll see how it goes. So this is what we built. So we have here some code in there from various public GitHub repositories. We're able to search across this already with the tools that we have. But we also have this chat box now where you can ask arbitrary questions. And we have some standard prompts near the bottom. Those are not scripted prompts. Those are just really that string is all that you see there. And then from there, we have a model that is able to call tools that we have to search for a recipe, run that recipe, see if there's any kind of useful results, and then from there, analyze the results. So let's see if the Anthropic API is working today. So what we're asking is, how am I using Apache Commons? I could have plugged in anything differently. I could have asked for the Beek lines that are used across the organization. And then you'll find that it first executes that search that we have. So this came back with a couple of options. And from there, it selected the find methods recipe that we already had and have been having for about a decade by now. And then it figured out that it will need to check the options available to that recipe. It didn't know the recipe specifically, but it was able to ask for the options to pass in there. And then from there, it figured out, well, I should ask it add this pattern that we need to fill out these options. Again, why I said documentation is suddenly very important. It's just developers ignoring it, but also AI trying to read it. And then it actually runs that recipe for us. So again, something we already had, but now executed by AI. And then the results that come back is something that it's already able, if you give it a tabular format, to write a query to process that with DuckDB. And then you're able to get summaries like this one in natural language saying, well, you're using all of these various Apache Commons libraries. You're using specifically these categories like configuration, string utilities, logging, all of this. And this then helps drive you to, okay, now that I know how I'm using Apache Commons, maybe what's the next step? I maybe want to move away from things, or I can ask like, can you generate me a histogram? And again, this is something that we haven't taught the thing. It's an agent, and you can pretty much plug in other agents here as well. Like I said, we're using Anthropic, but you can plug in other ones as well. And that again comes down to what our customers need. They want to have control. They want to be able to plug in their own models if needed, something that is sanctioned in the larger organization. And then you get something like this. It's a histogram, text-based, but it does show you a bit of how things are being used in this organization. So this is fairly simple to build. You expose your tools, you get an agent, you run things, and you can do so with the things that are unique to your organization, all the same, just using some small prompts and get it working. And then let's switch back to this one. Nope. Let me try to get that one. Slideshow. Okay, so you've seen this. My sales colleagues, they had an absolute field day the moment that this became available, because suddenly they could ask all the questions that they had to a prompt that actually ran recipes and gave them results, up to the point where I did start to consider that this was going to change my workday as well, because suddenly they're going to ask that bot instead of me, and I could be doing something more interesting as well. But like I said, it is a challenge bringing this into some organizations where every time you build anything, you have a 20-page questionnaire that you have to fill out. And if you tick the box for AI, you get another 35 pages to fill out on how you're using this and training this and all of that. So it is a challenge bringing this into larger organizations. But if you, like I said, build it on the basis of bring your own model and having those models not be the differentiator, but the tools that you're exposing, then we found that even banks and large corporations, they're able to leverage this type of technology. And then the neat thing is that our colleagues are now also able to ask the questions that they're kind of, let's say, embarrassed to ask at this stage, where they've maybe been with the company for a couple of years, because the bot will answer them fairly anyway, without judgment. And that then brings us full circle, because like I said, initially we had high hopes for generating recipes to expand the recipe catalog and allow all of you to migrate your own applications to the next thing that comes out, maybe that JUnit 6 that's coming out at the end of the year. And what we found is that there's been a lot of investment into the authorship part of using AI for code. So if you use Copilot or Juni or anything in your IDE, you'll have seen the results become a lot better over the past year and a half, up to the point where we are now confident in giving a wiki page of a migration guide, handing it off to Juni, and it'll come back with a recipe that might even compile. And then might be able to run it, and then through, especially Juni, with the iterations of analyzing any failures that it sees and running it again, they are now able to generate something that does actually work. And we have had some interesting steps here where we found that we at sometimes had to change our API to be more responsive with the way that these tools operate. Because what we found is these tools are very well able to generate recipes in languages like TypeScript or even Python, whereas we supported mostly Java up to now. But that, of course, is a compiled language. It doesn't allow to run it inline, whereas by now, also exposing our same visitor pattern as a TypeScript API, you're able to generate a recipe inline from that tool that we have, run it directly, and then see the results produced. So it's a very interesting development there, that now, a year and a half later from when we first started, we actually have something that does work quite well. But I do want to call out that while that is promising to see in action and maybe even feels magical, you shouldn't ascribe too much intelligence to the process itself, because it's generating code on a pattern that it's learned from the 4,000 recipes we already have, but it doesn't translate well still to changing millions of lines of code. So while it is very good at writing one new class, pretty much if you want to run changes on a very large scale, we still suggest that you use rules-based recipes to do so. And of course, authoring those has become a lot easier right now. So that's the recommendation that we have now is if you want to make changes at scale, don't let AI loose and start to reshuffle your switch case statements, but write the rules with help to be able to do so instead. So then, briefly wrapping up, I know we're a minute away from lunch, so I'll keep it short. You saw us use various technologies to be able to use AI. So we started out with a small building block search for recipes, which we've been continuously using within every step of using further solutions that we've built on top of that. And we found that modularization is very helpful. You want to have something that provides guidelines, like a search, which has been validated to work on a test set that you know to work well now. And then from there, have that be the boundaries that other operations operate on. Because if you're going to run anything at scale, you want to probably use something that is rules-based, and then be able to guide it towards that using AI is the way that we found allows you to do this as well. And then every step beyond that, like I said, choose a MCP with tool calling, use the tools that you already have that are differentiating for your organization and expose them in that way is something that is going to help you deliver value much the same way that we have for your own organization as well. So with that, I want to thank you all for your attention and then hope to see you at lunch. Cheers. And this, the QR on the right goes to that book if you want to read more. And the other ones are just to learn more about Open Rewrite, things that help you locally, or Modern if you want to try things out. Yes.